Good morning. Dr. Prerna, if you allow me to share the screen. So I am traveling. I just wanted to show the town to students because we still have only 30 students.
Yeah, sure.
Yeah. Okay. Okay. I really don't know what you are seeing there. Are you seeing my face or you are seeing the outside?
And now we are seeing the outside.
Okay, okay.
यहीं पे चालू कर दो। वो टाउन दिखा रहे हैं।
Hey, we are starting in like 1-2 minutes, okay? Okay, good morning. Okay, good morning. And I hope you enjoy a little tour of this town. It's called Morgantown, West Virginia. It is 1 hour south of Pittsburgh, Pennsylvania, and about 3 hours west from Washington, D.C., if you have heard these names, okay? Okay, so first business today, I think I provided you all the slides, okay? So I hope that you have done your homework, right? Let's see what we have. Let me share my screen now. Okay, so ready for the quiz.
Hello, sir.
Yes.
Sir, how to respond to this quiz?
Yes. Give me 1 second. You did not attend yesterday.
Actually, I was late yesterday. I posted
okay, no worries.
my
No
query
worries.
in
I
the
will
chat box,
explain.
but nobody responded.
Manbir, I am so sorry. Okay,
No,
let's do it today. So I will again. You need to go to this kahoot.it, type your name, and then it will ask you PIN. So this is the PIN number that you either you do this or you scan this barcode on your phone. Okay, thank you for coming forward and asking this question. Okay, Manbir.
thanks.
Yeah. So if you are joining late, you need to go to this kahoot.it, type your name. Means generally I'm asking that you should type your email ID, but probably this may not be allowing you that many characters. Okay. And then type this PIN, game PIN. Okay.
So if you are joining late, you need to go to kahoot.it, and this is the gain pane. Okay. Please note that if you are not speaking, please make sure that your mic is muted. Okay. Okay, maybe 30 more seconds. Okay, and then we'll start the quiz. So if you have seen the quiz on the last lecture, and if you have not, I will just give you a little bit what you have to do. Okay, so you will see the questions and you will see 4 choices or 2 choices, true and false in that case. And on your screen, okay, that you will just see the color. So you need to see which color matches with the text, means multiple choice. So you just need to click that color. Okay. So on your screen, you will not see the multiple choice text. You will just see the color or the shape probably. Okay. Diamond and a square or whatever. So you just need to click the color corresponding to the text that you see on the screen. Okay, then let's go. Okay.
Sir, where to click?
Did you not go to the kahoot.in?
I again go to the Kahoot.
Yeah.
Okay.
Manbir, you need to go to kahoot.in.
Okay, okay, fine. I got it. I got it.
Okay, then. Okay.
Yes, I got it.
Okay, very good. Very good. Okay. Okay, it definitely is telling that today is Saturday. Okay. But I'm glad that all of you could make it. Okay. Okay, 10 seconds. I would have set it up a little bit more seconds here, but yeah. Okay. good. All are correct, right? We discuss all 4 types of agents. Okay, again, if you are trying and if you are not getting correct answers, that's perfectly fine. But trying is important. And if you have read it, that is important part. Okay. So do not be disappointed that I am not getting it. Okay. Because it's extremely advanced level, like even first, second year or last year of MS or first or second year of PhD. Okay. That level we are talking about. Okay, few minutes, not few seconds. Yeah. Okay. Of course, differential, right? Okay, Trinath is doing very well. Okay. Okay, zone 3. There is no zone 4. Okay, I just made it up. Okay. Okay, very good. Okay, very good. We have still one student, huh? Okay. True. Okay, Trinath is keeping the lead here. Okay. Very nice. So IMP is impedance, okay, low or high impedance faults. Okay, so in the application that we discussed, that was about 0.608 seconds. Okay. Okay, we have Monica coming up, Srimati, and I don't know the second person name. Okay. Okay, absolutely. Very good. Amazing, amazing. So you have still one student. Okay, I think if you are repeating means all the time, so that means something is not right. Okay, you have to pay attention, or you have to read again. You have to read again, read again. Okay, that's and figure out where what you are missing. Okay, so if this is, and of course that this material is not just enough, right? You have to read extra material to understand deeply, right? This is just kind of concept material. But if you are keen to understand, keen to learn, and the feedback for you is that, and if you are getting the answer wrong, even after going through all the slides, right? So you have 2-3 times, okay, and understand every single sentences, okay, every single things that was being presented there. And I'm sure Dr. Prerna will provide or maybe uploaded this video on YouTube, okay, so you can look at it, those videos, search for additional material, read. That is the only way to understand. Okay. Okay. False. I just little bit tricked. Okay, I tricked it a little bit. Okay. So I see continuous Trina, Srimati, Monica, and 2021 on the screen. So that's good. Okay, very good. Not parallel compensation. Again, I just made that up. Okay, not reliability. Okay, that again we did not discuss about that one. Yeah. But maybe a byproduct. Okay. False, right? Remember, for magnitude, reactive power relates to magnitude and active power relates to the angle. Okay. I don't know how come we have 18 students. Okay. This is very basic. I already gave up the answer for this one. Okay, Trinath is copying Monica. Now I think I'm seeing Sunita first time. Okay, very good. Okay. Okay, very well done. Okay, very little, but majority are good. Okay. Okay, very good. And the last question. Okay, and we still have a Trinath leading. Okay, and looks like, let's see. Okay, very well done. See the podium. Okay, 17 out of 22. Very good, Sunita. 19 out of 22. 2021 EEM 1038. Okay. And today's winner is Trinath. Okay, good work, Trinath. And the good work, Swati and Yuvraj. Good work. Okay. So again, it's not magic. Okay, if you couldn't do it, it's not magic. It's everything was given. You have attended that lecture for 3-4 hours. Okay, and you got almost a day to work on it. And if you have spent time and if you really read it, okay, and if you couldn't do it, okay, the way to do it is just practice, 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 and practice. Okay, and if you don't understand it, search related material, read their abstract, go through that probably book. So you have to spend time. There is no magic here. No one gets it without working hard on that one. Okay, so please understand all the students here. Okay, it's better than the last quiz. We had like 33% score. Now we have 47%. Okay, so probably that's good, right? So now you understand what needs to be done at least. Okay, it tells me how many difficult question I can assign all difficult question again to all the students. Okay. But okay, then I will stop sharing. Thank you very much for your participation, and I hope that you enjoy the quiz. Okay. And let's see, where is my presentation here probably. Okay. Okay, so I will just start the lecture today. Okay. And quickly go through, revise quickly what we talked about, important points, different interconnections we talked about, right? Who is responsible? NERC responsibility is reliability standard. FERC responsibility is interstate, regulating interstate transmission. Okay, even if they create the proposals and fund those proposals. Okay, very important. I was actually giving you like a little bit a tour, and then I was speaking. I did not know that my microphone was off. But I said that all our buildings here are completely enclosed. Okay, not open air. No, there is no windows that you can open. So it's centrally air conditioned, centrally heated. Okay, and that is the reason that our consumption is much more than the India's consumption here. Okay. We talked about a little bit about the restructuring, right? Vertical and horizontal on this one. Very important, the consumption here, right? And we want to grow. We want to grow as much as we can. Okay, 99%, 100% would be nice here. We talked about GMS, different modules of the GMS, generation management system. Lot talk about unit commitment. And then we talked about energy management systems, right? Different modules, overview on that one. Distribution management system, lot of distribution centers are coming up, control centers. They see the value for doing that. Okay, that is why it is coming up, right? And then a little bit of restoration module. This is actually the module that I developed in the company. Okay, so I was leading a scientist or whatever you get, a developer in power system group. We talked about basics of agents, right? Different modules, different characteristics, right? Objects and agents difference. We talked about agent architecture, horizontal, hybrid architecture, right? Horizontal, vertical, and different things we talked about, right? Different reactive architecture, characteristics, different agents, right? Software agents, interface agents, and then the actions and C functions of the agents, right? And then a lot of applications. In last lecture we talked about. One is the biggest one is protection agent. Big deal, this one, for if you can do it for any company, any utility as a project, senior, what do you call it? Your master's thesis project. I think you have done a tremendous job because government is funding you for your master's thesis, right? So you should take advantage of it, right? Means if you don't take advantage of it, then you are not going to progress. Very simple. Different interactions, okay? We talked a lot of details about all these agents, detailed discussions on network, simplified network. And then this is the one that we talked about, right? 3 minutes and 17 seconds, a lot of alarms, right? So 3 applications of MAS with respect to protection we talked about. This one is distance relay, right? We saw that current without MAS, current was lasting longer time in the system compared to with the MAS. The current was lasting, fault current was lasting few milliseconds, right? Or 100 milliseconds, what on this one. Then differential transmission schemes that we talked about. I would say this is like last lecture also I mentioned, go, if we can do it for every single elements in the system, that's the ideal thing if we can do it, okay? That way we know exactly where is the fault, because that differential scheme works, okay, as far as you have proper communications, right? Little bit about market, okay, and I think you did good on the quiz. Control path, right? Parallel path, we talked about the control of power, PQ control. Very good. I think this was good applications, right? Of fax devices. These are the control paths. Okay. And then I think we were here. We discussed one on one. So we reviewed all the material that we have done so far. Okay. And so today, I think we did one scenario for this system. Okay. We saw that when you have this kind of system, okay, you have SVC here, okay, and then STATCOM here. And when SVC is fully injecting its capability, right, to maintain the voltage. And when this voltage is still below its limit, right, violating the, so this agent goes to this agent, right, STATCOM agent. And STATCOM agent is seeing good voltage at its bus. So it's not doing anything, right? But now it's probably lower side of its limit, right? Means lower side of the bandwidth that this agent has, right? And then with coordination, this agent means it's this STATCOM basically inject more reactive currents, right? And then we get the good voltage here. So that is one thing we discussed with and without, sorry. So this one is, and this one with and without, right? So with secondary control and without secondary control. So that's what we mean, right? And we can do it because in secondary control, sometimes you have 30 minutes to continuously seeing the voltage is violated. Sometimes you have seen operators seeing 4 hours, continuous 4 hours, because they are not far from the bottom limit, okay? And so they let it go because mostly transformer taps, when it is utilized in the distribution side, it's will be correcting that part of it. So, but if we can correct on the transmission itself, so that's a good thing, right? Okay, so second scenario, I think this is where we left off, okay? Scenario 2, when scenario 2 occurs at 5 seconds, the voltage violation was found by agent SVC, and it cannot be removed by itself, okay? SVC agent sends request to AVR and STATCOM both, right? And we discussed that. I think we discussed this one. AVR decides to respond by increasing its voltage reference setting to 1.05 at 8 seconds. So this one is second scenario. I think we did not discuss, sorry. Okay. At 9 seconds, a second request was sent by SVC to STATCOM And at 10 seconds, it is increasing the voltage on STATCOM side, okay, to compensate. So in this one, we have all the agents are helping to basically maintain the voltage at SVC. So we have agents from AVR, it means AVR agents, generator side, STATCOM agents we have on this side, okay. I'm maintaining this one, 136 here. Okay, and then these are the responses that we see, okay. So we have with secondary control, high side of the limit, without secondary control. So this is and then where is the violation that we are seeing? So this one is, this is where VSC control, right? And this one is AVR. So AVR is not doing anything because at its terminal, okay, at its terminal, it is seeing the voltage within limits, 1 per unit. That's a good voltage, right? And but SVC is seeing the voltage is violated, right? Below 0.95 here. Okay, so it's taking help from both controller, right? AVR here, and then STATCOM control here. And again, you can see here, the STATCOM is not doing anything at its location because its voltage is within limits, right? But addition, little bit addition it can do, and still within the limits, still below 1.05. We are not able to see it, but most likely it should be at 1.05. So within limits, and we can help this agent, we can help this bus to keep the voltage within limits, okay. So again, for this kind of development, you need to do detailed study on this one. Detailed study, lot of simulation, Monte Carlo simulations, I say, okay. Do not be like, what is Monte Carlo? Monte Carlo is lots and lots of simulation, okay. So if you run a power flow, let's say just any power flow you take available, and you just for loop, okay, and just put the load curve 1 week or 1 day load curve, maybe every hour. That's a Monte Carlo simulation, okay. But now if you change some tap setting, adding little bit more, then you are giving meaning to that Monte Carlo simulation. So it's a set of simulations, okay. That's Monte Carlo simulation. So whenever you read papers, so don't get like, oh, what is Monte Carlo simulation? It's just a lot of simulation, basically, okay, with lot of different conditions. Okay, I think this will be, okay. In this slide, this will be the last applications, okay. So multi-agent based voltage control of STATCOMs to enhance elimination of voltage disturbances in power system contingencies, okay. Here, they developed 4 agents: servicing agent, bus agent, load flow agent. Now we have, so this agent can do load flow, okay. And then we have another agent, so that is probably definitely this will be AC load flow, and this will be DC load flow agents, okay. Can this one? Okay, so servicing agents, SAs we call it, right? SAs respond to STATCOMs and can provide only shunt reactive power for power system in a specified bus, right? It's very similar to one that we just discussed, right? And bus agent can monitor their buses and have no service to provide. Bus agent can't provide any service, but it can monitor and it can send an alarms to this agent, right? I have a problem with the voltage or whatever. Load flow agent, who does load flow calculations. For implementing MAS in power system, the load flow agent plays the role of power system environment, okay. Load flow agent plays the role of power. If you don't have the physical system, generally none of us will have the actual power grid, right, to play with. So if you have some kind of RTDS or Opal RT, or even this kind of simulations, load flow simulation, I think that would be sufficient for implementing our algorithms, our agents, right, in a meaningful manner, right? And if you can show it to 2 different systems, small and large, I think during your time in as a student, I think then you have done a good job on your thesis or dissertation. Other agents that need to know their voltage values and other system measurements get their status from this agent by sending the request, okay. So basically, you can you can run power flow in MATLAB. There are now a lot of power flow models are available in MATLAB, the distribution power flow, 34 node, I think 13 node power flow. And then you can run that as your environment and get the parameters from that from MATLAB and send it to agent through maybe a text file. Okay, so you dump the data from the MATLAB Simulink to a text file, and you have the agent running in Jade. Okay, and that agent is reading this data. Okay, and then communicating and taking actions. So you can dump the data into the text file. You can also read from the MATLAB, and you can also read the data from the text file into the MATLAB. Okay, so if you have any control switches or if you have any settings like transformer taps or capacitor settings that you want to change, you can read it from the text file. Okay, and that information is coming from the MAS, and then you can set up a kind of this environment and agents, right? Environment is in MATLAB, and the agents are in really agents, right? Synchronously communicating onto the, so you can do everything in one computer basically. DC load flow agent, which can be created by instantiating load flow agent to perform DC load flow and sensitivity analysis, right? Sensitivities, many times I mentioned in last lecture. Very important, right? But understanding, if you understand the Jacobian matrix of the power flow, that's what is the sensitivity. Okay. Process of coordination. Each agent monitors the voltage of its own. Okay. Once a bus agent detects a voltage violation, it searches the directory facilitator, okay, for available agents, right? Service agents. The service agents which have low voltage sensitivity with respect to the requester bus agent will be ignored for collaboration, right? That's exactly I was mentioning, right? So you need to study your system, right? And then you can say, okay, these are the sensitivity. I'm okay. If anything, when I change more than 5%, I want to incorporate that as my reach from that agent. So if you are changing capacitor control at bus 1 and bus 2 or bus 3 or bus 4 are changing for up to 5%, then all these buses are reason of influence from that particular agent. Okay, and anything below 5%, then I will say my agent is not influencing. So you have to study the system to decide whether really is going to help, because sometimes when you change it and you probably creating violation on another bus, right? Because as soon as you inject the reactive power into the system, then you are basically increasing the voltage all over wherever you are influencing. Okay, so very important to study the system. BA bus agent sends service agents call for proposal message, okay, CFP, to know the maximum collaboration service agent can provide. Okay, so how much service agent, because based on the sensitivity service agent needs the sensitivity information from probably the DC load flow agents. Okay, so service agent checks its capacity and its own voltage. It computes its maximum collaboration based on its available capacity and voltage of other remote control buses. Under its supervision, it sends back a proposal message to the source of request to tell its offer of support. So everything, once it checks and really that it is going to help that bus agent, then it will say, okay, I should be able to support you. I will probably increase the voltage or decrease the voltage, whatever is the need for that bus agent. Right? Bus agent receives all of the service agent's responses and offers. It gives this information to decision-making unit. Okay, sorry, I said this one decision-making unit. Okay, somewhere I said directory facilitator. Okay, no, this one is directory facilitator. Okay, decision-making unit. This one is decision-making unit. So BA receives, so bus agent receive all of the service agent responses and offers. It gives this information to decision-making unit. Okay. Decision-making unit selects service agent based on optimization. Okay. So now let's say if you have 4 devices, that are going to influence your bus voltage, right? Where you have a violation, right? So how you can decide? Okay, so here it is saying that we have to do some kind of optimization, okay, before you say, okay, this is the best one for us out of 4. Bus agent sends request messages to selected service agents to do the proposed action he wants or she wants. Okay. So bus agent is deciding, bus agent is coordinating with all other agents, right? All other agents. So much involvement, so many communication messages are being passed before coming at the conclusion, okay? Who is going to help this bus agent to mitigate the violation, okay? Service agents perform the proposed actions. They send an informed message to bus agent about termination of their actions. Okay. If the voltage violation disappears, the agent returns to the normal states. When a service agent runs to perform an action, it must go to block action state for a short time. Okay, it is because avoiding over injection. Blocking time can be defined based on problem conditions, right? So again, you have to study, right? So how long you can block the actions of this service agent, and it is still gonna be valid for your system. If service agent detects voltage violation on its own bus, okay, it will do its action locally and will block other requests until violation gets eliminated. Okay. Also, it will deregister itself from the directory facilitator agent and act like a bus agent, basically. Okay. So it's saying I am controlling my own bus. I am trying to resolve the voltage violation if I can. Okay. And so that is why I'm not able to give any additional services. So I am already busy, basically, this service agent is saying. Okay. This is 39 bus system, if I'm right on this one, looks like 36, 38, 39 bus. Okay, so this is 39 IEEE 39 bus system. So if you are familiar with MET power, if you are not, then every single student attending the class should be, right? MET power is the basic. So you should be familiar with that software, okay, whether you need it or not. That's important. Okay, how to use it, you will need it throughout your career. Okay, and it's good to understand. And if you can't understand, at least go through all their methods. Okay, see how they are implementing, what's going on with how they are using the input data case files, and how they are taking into the programs and running the power flow. And at least as a master student, just debug that and see how they are creating the Jacobian metric. So do the calculations for 3 bus, hand calculation, okay, and see if that calculation exactly matches with that 3 bus system in MET power. Okay, if you do that one, I think that would tremendously help you in further study applications, so you know exactly what is happening in the system. Okay, so MET power. And still, I think it's open source. You still see the code. Probably 10 years from now, they will block it. Okay. Okay. So StatComs are installed 13, 14, 33, and 37. Where is the 13 bus? Bus number 13. I see 14 here, 13 here. So we have a StatCom here, right? 13 bus. Then we have a StatCom here, 14 bus. Then we have StatCom at 33, and then we have StatCom at 37. Okay. So we have so many volt generators, we have so many transformers, still we need so many StatComs on this one, okay? So let's see. So at first second of the simulation, the load as bus 15 increased by 10%, which lead to voltage drop as bus 15, okay? So let's see bus 15. So we have 15, okay, and we have the StatCom here. So this load is increased by 10% and then creates the violation at this bus, voltage violation, okay? That is the first case. At second, the transmission line between nodes 15 and 16 was lost. That led to voltage drop as bus 15 below the constraint of 0.95. Okay, so line 15 and 16, 15 and 16. So this line goes away. Okay, so you have the increase in load, you already have the violation. Now this line is gone. Okay, once this line is gone, it is saying that below the constraint 15 voltage. So here it is dropping the voltage. Okay, so it's not violating the voltage. In the first case is not violating, but when we increase, so when we increase the load here, right, the voltage is down. That is generally the case. When you increase the load, voltage will go down a little bit. Okay, but it's not violating. But when you remove, this line is removed for whatever the reason, right, and then you have now the violation. Okay, it goes, the voltage here goes below 0.95. Okay, and very simple, you can just go to that IEEE 39 file, you can remove it, this file. Okay, you can go to the load data on that case file, increase it, and just run the power flow and see this voltage. Very simple. Okay, so you should be able to see that one if they have not changed the data. Okay, for their purpose. Okay. Okay, so we got first, second voltage load increase, we have voltage drop, and in the second we remove the line 15, 16, and now we have a voltage violation at bus 15. The agent located at bus 15, bus agent, right, detects this voltage violation. It searches the directory facilitator for available service agents and find 13 all 4 agents, right? So this bus is so important that this bus is in kind of influence regions of all the statecom. This bus, okay, this bus 15 is influenced by all these 4 statecom. Okay, that is generally you will not have this kind of. Okay, but I don't know. Okay, but general speaking, all the 4 this can impact one single bus. It's just unusual. Okay, but again, academic case. Okay, it can happen anything. Okay, but understanding for us, we want to understand what is happening with multi-agent system. Okay. Okay, so now bus agent 15 sends call for proposal for this service agent, all the statecom agent. And since all service agents are in normal mode, they reply it with proposal message and collaboration amount, that this is what we are going to collaborate. Okay, all 4 agents saying that we are going to collaborate to increase the voltage of this bus. Okay. Now bus agent 15 calls the decision maker unit, right? Now he has to, that decision maker has to run whole system probably, okay, to provide the best action for the state. Okay, this decision making unit decides that only SA14 must inject the reactive power of 1.5 per unit. Okay, now see what happened now. It makes sense also, right? Means the voltage that we have violated on bus 15, there is no line. So the influence that 14 has more influence on bus 15. So statcom at bus 14 has more influence on bus 15 voltage rather than statcom at 33 or statcom as 37 or statcom as 13. 13 also will have, depends on how long is this line, 13 to 14. Okay. Okay, so decision making unit decides that only SA14 must inject the reactive power 1.5. Again, remember that agent doesn't know all these things, right? Means we can see it. We can see that what is going on, who is near, right? Who is far. So all these things that what we can see, we have to inbuilt, we have to program it in the multi-agent system. Okay, to do that. So the agent, yeah, okay. So now it is saying that just SA14 should inject 1.5 per unit power. Okay, so bus agent 15 sends a request for reactive power injection to service agent 14 at bus 14. The action of this SA at the 3rd second increases the voltage at bus 15 and clears the disturbance effectively and rapidly, and also without involving any additional support. So that is simple case, very simple case, right? But it is still demonstrating all the collaboration, all the message passing between everyone. Okay. Okay, I see a message long back. Dipayan, I try to find first of all because I did not promise. Remember, I said I'm not promising, but I still put at least 10-15 minutes looking at papers. Okay, I couldn't find it immediately. Okay, so probably you have to search it. Okay. To carry out sensitivity analysis, it is desired to formulate the Jacobian matrix of the studied test bed. Then how will we quantify the mastery of MAS for coping with unmodeled dynamics? All right. So unmodeled dynamics, that's unknowns that we have to either build it, and if we can't build it, then we have to live with it, right? Means remember, like we saw that there are like 15,000 alarms. So for just one human being, it's just impossible to analyze, right? So how you can do best, how you can build a system that can see everything that needs to be seen in that system. So you need probably a couple of experienced uh, operators that they have seen those incidences in their system, and they share their knowledge, and with their knowledge, and then lots and lots of simulations that you have to do, and then only you can probably deal with unmodeled dynamics. Okay, Deepayan. So yeah, means whatever we can do best. We cannot do every single thing, right? When we are doing as a student, right? When you have a project, so you can't do everything. You just need to focus on that project, that aspects of the project, right? So these are some of the results right here. What we see, voltage is at node 14 and voltage is at node 15. Okay. So at the 3 seconds here, voltage has improved. Here, voltage has improved. Both voltages are almost within limits, right? Bus 14 and bus 15. So bus 15 was violated, right? Remember the load and line is outage. So when load increase, this is what happened at 1 second. When 10% load increased, the voltage came down, but just a little bit, okay? And after line outage, the load bus voltage below 0.95 and much far from the 0.95 violation limit, okay? Dipayan, hope that helps, okay? Okay, so now test 2. At 1 second of this simulation, the load bus 15 increased by 20% now, which led to voltage drop as bus 15, okay? Also because of exceeding power transfer limit of the line between 15 and 16. At the second, this transmission line was lost. Okay, let's see, 15 and 16 is still the same line, okay? Second scenario, same line. Okay. Because of this line outage, the voltage at bus 15 dropped to 0.914 unit. Okay. So again, bus 15 violates the agent located. Bus 15 detects these voltage violations. Okay. So bus voltage detects. Now BA15 calls decision-making unit for a proper action. Decision-making unit suggests that not only 14 must inject this one, but also now SA13 must inject 0.75 per unit. Okay, and if you can see that one clearly, that in the scenario 1, when we had 10% voltage, 10% increase in the load, our voltage went here, and by injecting 1.5, probably that may be the max limit of the STATCOM at bus 14, right? So bus 14 is engaged, and then we are just barely reaching the minimum voltage limit at the meeting the lower side limit of the voltage at bus 15, right? So it makes sense here that, okay, we probably will need 2 STATCOM here, okay? Okay, so we here, sorry, we were here, okay? So first second of the simulation load bus 15 increased by 20%. Okay, so this is 147. Again, going back, 15, we are increasing, instead of 10%, we are increasing the load 20% at bus 15. Okay. And then 147. Okay. Also because of exceeding power transfer limit of the line 15 and 16. Okay. At the second, this transmission line was removed. So we are removing the line 15 and 16 here. Okay. 15 and 16 here. Okay. And then we definitely have a problem with bus 14, bus 15. Now the bus voltage is 0.914. Okay. Here, what was the bus voltage was 0.92 something here in 10% load increase case. And in 20% load increase case, after removing that line, okay, after removing, I'm going, moving a lot, okay, so just pay attention, 15 through 16, after removing this line, when load has increased by 20%, okay, now this voltage is 0.91 something, okay, it's saying, okay, so that is 0.91, definitely is violating the voltage limit. So an agent located as bus 15 detects this voltage violation, okay. Okay. Now BA15 calls the decision-making unit for a proper action. Decision-making unit suggests that we need statecom 14, okay, and statecom 13, and both should inject this much power, right? 1.5 and 0.75. So at third second, by action of SA14, the voltage rises to 0.943, not enough, right? And then and yet is below the acceptable 0.95. Now 3.2 seconds, okay, so this is third second, and 3.2 second, 13 statecom at 13, right, removes the violation, clears the, because it is injecting 0.75 additional reactive power into the system, okay. Now if you see here, at 1 second simulation here, okay, so this one, your voltage is going down because you increase the load at bus 15 by 20%, okay, and then at second you remove the line 15 and 16, okay, line 15 149, line 15 and 16 you removed here, okay. Now the voltage went to just near to 0.91, okay, 0.91 here. Now at 3 seconds, your statecom 14, right, is injecting the reactive power. You are not near to your lower limit, okay. Now in 3.2 second, your another agent, what, right, for 13, right, so one is 14 and 13 is injecting. Where is the 13 here, so here, right, the next best statecom, right, this is the nearest one, at least from what we are seeing here, okay. Unless this line is very, very short, then there may be a different scenario, right? So, but if you can see here also this line and this line, so it depends on how long is this line, 11 to 33, because in 33 also we have a statcom, okay, and then we also have another statcom at 13. So depend on this line impedance, okay, or how long is the line. So 149, and then we have so this is coordination, right? We are removing, able to utilize this, okay, this one, okay. Third scenario, okay. So at first second of the simulation, the load 15 increased by 30% now, okay, which led to voltage drop as bus 15, okay. Again, we are removing the line 15 and 16, okay. Now voltage drops to 0.9, okay, 0.9 per unit. Before any action to be done at 2.2 seconds, the transmission line, another transmission line is gone, 30 and 13, okay. So two transmission line gone, 150, okay, 13 and 30, okay. So that is one more line gone, this is line. So we have 15 and 16 out here, okay. Let's say design, right, or insert. Where is my pen? Draw, probably draw. Where is draw? Okay, here. Draw. Okay, I should have done it before only. Okay, so this line is out, 15 and 16. This 13 and 30 is out, and then load has increased to 30%. Okay, that is generally unusual. Okay, but we are, remember, academic case, and trying to just see whether our program is working or not. Okay, Rohit is traveling with the family. Okay, so that's good. Rohit, be careful. Okay. Okay, so 159 here. 13 and 30. So two lines out. Okay, and then we have voltage much below the bus 15 voltage, much below the 0.9 per unit. Okay, much below the limit, lower limit. Now this event caused the voltage at buses 12, 13, 14, 15, and 32 to go out of acceptable voltage boundaries. So not only bus 14, but many other buses are also going, seeing the violation basically. Okay. So now we have 13, 14, and 33. Okay. Deregister themselves from directory facilitator because they are seeing their own bus violation, right? 13 violation, 14 violation, 33 violation. So what is going to happen? 15 is not going to get support from this agent for that particular time unless they are able to remove the violation for their own bus, right? Okay. So on the other side of BA15, searches the directory facilitator for available service agents and only finds SA37. Okay, so let's see 151. So this agent here, this agent can't help, this agent can't help, this agent can't help. The only helpful agent is this one, 37. Okay, let's see what is going to happen. 151, right? It was okay. All the registers, okay, and then we have only SA37 is available. Since the voltage sensitivity of bus 15 with respect to reactive power injection S37 is below the specified threshold, it ignores this SA and continues to search. Okay, now see, it's very clear, right? 151, if you see here, so 37 is much far from the influence region to this one. So whatever the injection it does, there will be very small effect on this one, very, very small. And the violation is severe, 0.9, is much, much far from the lower limit. So even if say 37 is available, it's not going to help this agent, okay? Okay. Okay, so let's see what happened now. Assays at buses 13, 14, and 33 perform local actions of injecting reactive power, different values, okay? By performing these actions, all of the assays go to servicing mode and re-register. So because by injecting this respective reactive power to these buses, right, 151, so they are injecting power 13, 33, right? And then 13, 14, and 33, right? So then their voltage now within limit, and they say that now we still have enough power, we have still remaining reactive power that we can supply, and then it goes back to service that we can support other bus agents now. Okay. Okay. So at this time, the BA15 finds all of the service agents and asks them their collaboration values. Okay. The assays at bus 13, 14, and 33 reply, and the BA15 with the proposal of this much, and this much, because that's maximum available, right? So DM at bus 15 decides the action that reactive power injection of this from 13 and 14 and 13, 14, and 33 will help resolve this, okay? Okay, so again, so I'm not going because we already discussed two scenario here, okay? And you can see that the bus voltage at 15 coming back within the limit, okay? That is, this one is 0.95 after doing all coordination and collaboration with these agents, okay? So this is 15% load bus 15 increase 15%, okay? On this one, or 30% probably. Okay, so many of the slides that we discussed are here for the agents are, I use these two books, okay? Wiming Sang et al. And then Michael Woodridge. That was the book for the introduction to multi-agent system. So I don't think you will need more than this for the power system. I think I extensively read this book and took the necessary information that will be needed for the power engineers. Okay, so if you are designing multi-agent system, these slides are just more than enough for you. Okay, just more than enough for you. You don't need to just go and read it unless you absolutely want to enhance your knowledge and you have time to spend. You have time to spend on computer science rather than power system. Okay, so I think it's a good time to take a break. Okay, and then we will start working on the next slides. Okay, so I will stop here and let's take maybe 10 minutes break this time. Okay, but I will come back in 5 minutes. But okay. Okay, then I think hope you got enough break. Okay. Uh, so, Dr. Prerna. Okay, thank you. I think I will share my whole screen. This one today. Okay. Okay. Now this is the expertise. My expertise in this one, multi-agent restoration. I have done a lot of work in this one. Okay, in the company, in my PhD, and lot of work. Okay, so and then I will give you today. I am going to give you mostly working example, practical example of MAS, that is existence and implemented in the United States. Okay, but not this one, in the next one. So this one is restoration, and in this one, the researcher made feeder agent, load agent. Okay, feeder agent act as a manager for the decision process, and load agent representing customer load. It can be used for large-scale distribution network. This multi-agent system. Distribution system configuration is radial in this one, they consider. Okay, so understand this one. So we have a substation A, substation B. In substation A we have two transformer, 3-phase 1A and 2B. Okay, and then in substation B we have 1A, 1B and 2B, two transformer. And then when you have substation, between substations, when you have a switch, that switch is generally open. Okay, and it's called tie switch. Okay, so that is C switch. This one is C switch, right? So these are all C type switch. When you close, you are transferring power between substations. Okay, this one. But now these substations have several buses right here, and a lot of customers here, lot of customers here, customers here. So we call it now feeder 1, feeder 2. Means here feeder 11, feeder 12, feeder 21, feeder 22. Okay, so you can, whatever this is feeder. Someone was probably asking me earlier, what is feeder? So we call it this one feeder 1, feeder 2, this line, right? Feeder 3, feeder 4. Okay, and then between feeders, okay, that is A switch, between feeders. So this one is between feeder. Okay, same transformer, then A switch. Between feeders, different transformer, then it's called B switch. So you have A type switch, B type switch, and C type switch. Okay, these are the switches available. Okay. Negotiation process is one of the key processes for the multi-agent. Now I think every single student knows about it, right? We have done enough discussions on this one. So what are the strategy in our restorations? We have, first, we want to take the power from our own substation, our own transformer. Okay, so that is A type switch. Then we want, if it is A type switch cannot do it, then we will want to do B type switch, because it's the same substation. And if A and B fails, or A and B are not available, then we can tap into the C type, right, switches, and take the power from another substation. Okay. What is the purpose of load agent here? So what we are trying to do, we are trying to do a restoration here, right? And this is the system. Generally, everywhere you will have this kind of systems, okay, but not maybe A type, B type, and C type. Mostly C types switches are C types, yeah, C type switches are available, not an A and B. Okay. Load agent. Purpose of load agent to restore the load directly connected to its associated area. Okay, that's the purpose. Okay. Rules: if de-energized, if load is de-energized, okay, if de-energized condition is detected, how do you detect the de-energized condition? Simple, right? Just seeing the voltage, right? Or maybe current. Current is not the right way, because if you turn off all your loads, right, then you will see current is 0. So better way to see is with the voltage. Okay. So if de-energized condition is detected, then load agent sends request message to feeder agent in order to restore its own load. Okay. If de-energized condition is detected, then load agent also opens the neighboring switches for preparing for restoration. So It sends the message to feeder agent. It's also open up the switches. Okay, if load agent succeeds the restoration, it offers the energizing actions to the neighboring load agent as well. Okay. Feeder agent, purpose of feeder agent to facilitate the negotiation process of multi-agent system. Right. What is feeder agent job? Uses A type tie switches first, then second is B type, and then C type, like we discussed. So in this one, we have a fault at load 6 here. Okay, so when we have a fault here, right, then this everything is de-energized. So first, load agent 7 to 10 respectively isolates its own load by opening the switches prior to the restoration process. Okay, so we have a fault here, 7, 8, 9, 10. Okay, 13 is part of the substation B, right? So this 13 is part of substation B. So feeder 1, 2, this is feeder 1, 2, 6, 7, 8, 9, 10. These are the loads that we have. Okay, additional switches, generally you will not have it, okay, everywhere, but depends how long it is, right? And how valuable that feeder is, whether it's supplying to Microsoft, supplying to Amazon, critical facility, right? So it depends how critical it is, and same kind of investment goes with that one. Okay, so load agent sends message to feeder agent 2. So this load agent sends message to feeder agent 1, 2. Okay. Now feeder agent 1, 2 saves this requirement from the load agents. So feeder agent 12 selects because of A type switch. Okay. Feeder agent 11 and sends. So feeder agent 12 selects feeder agent 11, right? So here we have 12, nearest one is 11, right? This one is same substation, but if it uses B type switches, right, then it will be different transformers. So our priority is first A type, right? So feeder agent 12 selects feeder agent 11 and sends his message with the amount of unserved load to ask for restoration. How do they know unserved load? Because these agents are measuring, right? They are saying that what our load before we saw an outage, okay, or before we had a fault, how much we were consuming, okay. So feeder agent 11 calculates available power, only load 7 and load 8. So now it calculates, right, and then say that the available power it can supply only to 7 and 8, okay, whatever is the reason is. So feeder agent 11 calculates available power for restoration and inform to feeder agent 12. So it calculates and it says I cannot supply all 4 loads. I can supply only 7 and 8. Okay. So feeder agent 12 send message to load agent 7 for closing switch A1. Right. So 7 is closed here and available power for the restoration. Now load agent 7 sends a message to load agent 8. Right. And both load will be restored. Okay. Next, now because this feeder agent is responsible to feed the power to all these 4 loads, right? And it sees that I still have 2 more loads. Okay, so it goes to where now it will go? It will go to its neighboring, right? So what is the available switch here? We have the switch here. Let's see, it's not visible properly here, but probably another here, right? So feeder agent here. So we have this switch. This switch is available and it is connected to the same substation, different transformer, right? Okay. So it will go to feeder agent 2012 as well, feeder agent 22. Okay. Okay, so load agent 7 sends a message to load agents 8 and both load will be restored. Now next feeder agent 12 selects feeder agent 22, right? So feeder agent 12 selects feeder agent 22 here, okay, and then to restore the load 9 and 10, okay, and ask for what is the capability, whether it can support these 2 loads or not, okay, load 9 and 10. Okay. And then Okay. And then if we have it, feeder agent 12, then it will restore the load. It will close that tie switch. It will close this on switch, and the loads 9 and 10 will be restored. Okay. So now this one is the more practical one. Okay. That is being installed in the United States, a multi-agent system. Okay. So understanding the symbol, right? So you have a current transformer here. That is, most of us know this one. This is the potential transformer getting the, so that are the measurements, current measurement and voltage measurement, right? And now you have a radio communication. How you are communicating? You are communicating with the radio, okay, with other agents. So this is very practical applications here, okay? And now you have a switch here, line switch, contacts open, this one is, and line switch is a SCADA mat or OmniMat, okay? So that's probably technical for we. And then we have this one, okay? Hold together, this one is breaker plus relay plus energy line communications, okay? Together everything, okay? And then three-phase power source. This one is this side. We have the three-phase power source here on the substation breaker. Very simple, okay? Very practical, doable, okay? So now think of this, this is local agents here because it has some kind of computing capability, okay? And computing and communication capability, right? Computing and communication capability. Every single bus, okay? So this is probably each device here is almost $100,000. Okay, each device is almost $100,000 here. Okay, so you can put it if you can afford it, right? And depends on your customer. So each is serving almost 50,000, 100,000 customer here. We call it 100,000, 1 lakh customer. Okay, so we have substation A, substation B here. Okay, and okay. Now see, okay. This is a lot of information, okay, but let's see if you can understand this one. So it is saying that this agent has a fault count equal to 4, and low voltage, I think, is low voltage count is 30. Okay. Now this agent is set as fault count equal to 3, VC equal to 4. Okay. VC is number of breaker trips, right? And number of breaker trips with fault current. So fault count, okay, to open a line switch. So when you can open this switch, when this agent has seen the fault current for how many times? 4 times, then you open this switch. Similarly, this agent has seen fault current 3 times, then you open the switch. Okay. Remember, these agents, these switches cannot be open or close open during the fault present. Okay, so these are not breakers, right? Only breaker has that capability to open up during the fault. Okay, now we see number of breaker trips without fault current to open line switch. Okay, number of breaker trips without fault current. Okay, so number of breaker trips without fault current. So you are seeing that no voltage, but you are not seeing any fault current, right? So that's the count of VC. Okay, LOV, number of seconds without voltage to open the line. So this is however you can design. This is how they thought it, that our systems would look like this one. Okay, so 30 seconds without the voltage, and then it will open up. Okay, remember, these switches cannot interrupt the fault current, then they don't have the capability. LS4, this one is normally open switch. LS4 is normally. Similarly for this side as well, right? So 30-second fault count and this one. Okay. Now all the switches are cold, supplying the load, okay, at this time. So this one is a normal operation. So this is 2 substation, kind of 2 feeders. Both are having 1 tie switch, okay, and at a couple of kilometers or couple of miles, you have this one communication, radio communication. Okay. Okay, so then you have a fault here. Okay, and after the fault. Okay, so now we have a fault here. That means this substation is feeding the fault. Okay. So now what is going to happen is that we are going to have a trip. Okay. So when you trip the breaker, okay, so remember this is a breaker. Okay, these are not normal, these are normal switches. So you are opening the breaker here. Now when you open the breaker, what happened? Number of breaker trips with fault current to open the line switch. So how many this agencies? This is first time breaker open and this agent saw the fault current. Does this agent saw the fault current? Because this is radial system. Okay, and this agent has not seen the fault current because fault is here, right? But it did when this line is open, it did see VC1, right? So number of breaker tips without fault current. Okay, so its setting is VC is equal to 4. Okay, so again, these are all local communication and coordination, right? So VC4, when it sees that VC equal to 4, then it will open up, right? So this agent has not seen the fault. This agent has seen the fault. This agent has seen the fault, right? And then their fault count will increase. Okay, so if you have read about it, the protection generally, there are many times in distribution systems are temporary. So temporary fault you will see, and generally it is cleared by itself. Okay, maybe two lines are like too much wind and two lines are touching each other. Okay, so temporary fault. Okay, and then it will be cleared. So generally they have a 3 times a recloser. Okay, so they will try three times. So okay, whether really it was a fault one time, whether it's again open and close one second time, open and close, and by that third time, if that fault is still there, then the breaker will keep open and it declares that there is permanent fault. Okay, that is generally the normal operation everywhere. Okay.
So
Okay.
green indication is that the fault is cleared and the line is disconnected, feeder is disconnected?
No, fault is there, but the green is indicating there is no power, there is no voltage basically.
Okay, and red means there is a power.
Red means there is a power.
Okay.
Red means there is a power. Okay.
Otherwise,
and then
normally we are saying red means alarming state and green means normal state.
Oh, not in power line. Not in power line. I don't know about India because most likely red means danger, right?
Yes,
we say red means danger. Yeah. So red means the power. Yeah. Green means go. Yeah. So that's how it is. And that's how it should be, because we don't want any lineman touching the wire, the live wire, right? So that is red means danger. That is generally the consider. Yeah. But okay. So good. Okay, now see what is happening. Okay, so it closes again, thinking that it is a temporary fault. Okay, when it closes it, it's still closing into the fault. Fault is still there. This is a permanent fault, right? Fault is still there. Then what is going to happen? This agent is going to see the fault. This agent is also going to see the fault current, and this agent is not going to, but it's going to see the voltage now, right? Then you will have the voltage here, right? Okay, but without that, there is no fault current. It won't be seeing the fault current. Okay, so again it will open up. Okay, so now what will happen? Fault count is equal to 2 here. Fault count is equal to 2 here, and the voltage count. So number of breaker tips without fault current to open the line. That is VC equal to 2 now here. Okay, VC equal to 2. There is no VC here because it's still seeing all these agents are still seeing the fault current. So this is FC becomes 2 here. You still have the fault here. Okay. Again, trying that may be a temporary fault, closing in. Okay, and that the fault is still exists. Okay. Now our current count is FC equal to 2 here, FC equal to 2 here, and VC is equal to 2 here count, right? So voltage, no voltage, okay, and no fault current basically. Okay, number of breaker tips without, that is because it's seeing no voltage here, but and then also seeing no current, fault current. Okay, that's how it is detecting this VC, and everything is local. There is nothing right now. There is no coordination. Okay. Okay, it is just, this is stripping, and these are all local agent measuring local values and increasing their counters here. Okay, now again it will open up. Okay, and now your fault count becomes 3 here, fault count becomes 3 here, right? And VC counts become 3 here. So what is this agent is programmed that when fault count is equal to 3, what is going to do? This agent is going to open its own switch, right? Remember that if this switch is closed and it's seeing the fault current, this switch cannot be opened. So this switch is not a breaker. So only breaker can open when the current, high current is flowing through it. So this switch cannot open because it cannot break the fault current basically. But currently there is no current, right? Means currently is de-energized. This green line is de-energized, okay, on this one. Okay, so now FC3, what is going to happen is that I have to open it. So local decision, intelligent, autonomous decision it is making here that I have FC3 and I open up. Okay, now as soon as it opens up, what is going to happen now, right? Now, when you close this switch, what do you think is going to happen? All the customers here in this area will get the power. Okay, fault is gone. Fault is now no longer. So there is no FC4 now here, right? FC3 is done here, right? Now VC3 here. Okay, so now what is going to happen? Okay, LS3 does not wait to open. Okay, LS3, VC3, okay, and again now we will have VC4 here, right, on this one or not. Okay, so it's, there is no, so L of V I think kicks in here, 30 seconds, number of seconds without voltage. Okay, and then it will open up this local decision it is making. Now it is counting the counter, right? LOV, no voltage for 30 seconds, it will open. So this automatically, it's just remove the fault. Okay, so there is fault is there, but that line is now not energized at all. So this line, so only customers that are affected in this area, they will not get the power. Okay, now we still have customer here. Okay, so we still have customer here. Okay, and this agent probably knows that I have to send a message here, right, and see whether I will be able to get power or not. Okay, so let's see. 2 questions. Okay, will I close this agent? This is normally open switch LS4. Okay, 2 questions going to ask itself. Will I close into a fault? Will I overload the alternate feeder? Okay, so if that is the answer is no, then it will close this one. Okay, on this one, and then this substation is going to supply the power, restore. So unfaulted area is restored basically, unfaulted area. So this is the beauty of the multi-agent system. Okay, but it looks so simple, right? But it's not so simple. Okay, what will happen? Let's say if you are here, right? If you are communicating, if 2 devices are communicating, okay, and there is a 12-lane road between these 2 devices. Okay, very practical. Okay, 12-lane road between devices. Sorry, and then in the morning and in the evening, too much traffic. Okay, too much traffic, then there won't be any communications between there because too much noise. You won't be able to get the signal, radio signal between these devices. So there are practical issues that you have, you will come across this when you are doing communication. So communication, as soon as you do communications, any type of communications, right? You have to be very careful because it will, you will see the problem that you have not seen before. Okay, so very important part.
Sir?
Yes.
Question please, sir. Sir,
Yes,
LS2, LS3, LS4, these are the normally closed switches?
LS4 is normally open. LS2 and LS3 are normally closed switches.
Okay. And these are the no volt contactor switches that those are set for 30, if they are not getting the low voltage for 30 seconds, then only they will operate.
That is correct. That is
Okay.
correct.
Right.
Okay.
Thank
Yeah.
you.
Okay. So MS wait for fault repair now, okay? And now MAS can be programmed to automatically return to normal, close transition, open transition with the signal, okay? Let's say fault is repaired, okay? And then this one, circuits are looped, and then it will open up, okay? And then you will get back to the normal state here, okay? Very practical. Sir, safety timer, okay? Circuit are looped together again. LS3 asks LS4 for permission to close. LS4 grants permission, and LS4 starts a safety timer. If LS4 does not hear from LS3 when the timer expires, this is what I was mentioning, right? It means communication. So you have to program it that if you don't get, what is going to happen, right? So if LS4 does not hear from LS3 when the timer expires, LS4 opens up, right?
Sir,
yes.
One doubt is there, sir.
Yes, yes.
So I can see here that the agents are trying to communicate between themselves through radio signals.
That is correct. In this,
Okay.
this practical application, yes.
Okay, so one thing more we can do in the control center, we can put agents into the network, and they can operate their own devices at the physical end.
Okay. Okay.
From the control center, the agents will operate the physical devices, so they can communicate in the network itself. So no radio signals will be needed.
Yeah, means if you trust your communication, these are all local, right? Means there is no central control center. Remember that we don't have a distribution control. So this is distribution system. We don't
but in
have
substation there will be a control center.
There in substation. No, there are no control centers in the substation. We don't have SCADAs in the substations. So we don't have currently infrastructure. 90% in the United States, 90% substations, we don't have the SCADA information. Like I said, just in California, 2 control center, distribution control center came in recently, like last 2-3 years. So we don't have the infrastructure. But yes, you are right. If we have infrastructure and we are sure that our communications is going to happen, yeah, then probably we don't need this one. Yeah.
Okay, sir.
Okay.
Thank you, sir.
Sure. Okay, return to normal is most valuable when a multi-agent system reconfigures due to a loss of voltage, which is then later restored. Okay. Okay. I don't know what is the second one. Okay. But I think substation, I think substation loses the power on this one. Okay. Substation loses the power. Okay. And let's see. So when substation doesn't have the power, okay, after 30 seconds, what is going to happen is it will open all the switches, okay? It will open all the switches here. And 2 questions, whether I will overload the feeder or whether I will close into the MV. The answer is yes, both of them. Will I close into the fault? The answer is no, sorry. Then only it will close this normally open switch. Part of this restored, okay? Then it will send that I have the voltage, another, let's close it, try it, okay? I have, and then most of your feeder is restored. As far as substation B has enough capacity to provide temporary, remember this is all temporary, right? Maybe a couple of hours, and then you can fix the fault and bring back to normal, okay? FC1, FC2, FC3, okay? So they are getting this now. Once they reconfigure now, instead of FC, so we had initially FC3, right, and FC2. So they are reprogrammed their agents that now I am reprogrammed that when I FC equal to 1, right? What is FC is equal to 1? That I am seeing the fault current and breaker trips once, then I will open it up. Okay, this one. Okay, now substation is back probably. We close it and then open it back to normal. Okay. Okay. So that is very practical applications of multi-agent system. Okay. Now let's see. Give me 1 second, okay? Stop share screen. Let's share this one. Okay. So probably I think this is the right time. I think we have enough knowledge, enough things that we have learned about it. So I think we already talked about it. There is a software called Jade. Do we have any software platform which can help us to develop multi-agent system? The answer is yes. It's called Java Agent Development Framework. It's a software framework that simplifies the implementation of multi-agent system. It's the middleware for multi-agent system. It provides agent services, life cycle. Okay, you can like agent can be born, agent can die. Okay, agent can move, right? So those are the life cycle services, white page services, yellow page services, message transport, all the infrastructure that you need basically. Okay, when we say infrastructure means all the programs that you need to build the multi-agent systems are available in are built in this platform, okay, framework. Tools to support debugging phase, remote monitoring agent. We have dummy agent, sniffer agent. So these are agents kind of sniffing our messages, okay. So if you send a message and if you can't see it to the agent that you are looking for, you can go back and look at the inbuilt agent that they have and see if that message is present or not. That means you have sent the message, but somehow it's not received by another agent that you are expecting, okay. This platform is designed to support scalability, right? And then I think we have an example how large agents that we have implemented later. From debugging to deployment, from small scale to large scale, okay, from 2-3 agents to hundreds of agents, okay, and fully implemented in Java. Java is independent, right? Platform independent. That is the beauty of Java, right? You can install it anywhere. Java is basically, or generally Windows and Mac, or probably Unix or Linux, right? Java technology is structured into 4 editions. Okay, so these are different editions of the Java, and probably now there may be a different versions of it. But a lot of handheld devices, smart devices. If you build your Java file, you can just use it any platform, any smart devices. A lot of parking meters, okay, are using Java technologies. A lot of parking meter, a lot of smart lights are using Java technology. So Java is huge now. Okay. No standards, no agents. If you don't have the standards, then there is no agent, right? It means you can say that this is agent, but if it is not following the standard, we generally can't say that this is an agent. Okay, so agents should have some kind of communication standard. So emphasize on semantics, interactions. Okay. That are protocols, negotiations, dynamic discovery, inter-organization, and inter-platform. Okay, that's open standard. The specs is openly known. Okay, the evaluation is controlled by an independent body. Open standard, right? Proprietary standard. The spec is normally not known until a late stage. Okay, proprietary standard, legacy system, I would say. Okay, when you want something from the legacy system like any GE equipment or any Siemens equipment, if you want some data, okay, and that is not already have the standard, then you will have a hard time. That's called proprietary. Those things are proprietary, we can't share. That's the answer you will get. Okay. FIPA is an open standard, and JADE decided to comply with FIPA standards. Okay, not FIPA World Cup. Okay, so FIPA standard. FIPA stands for Foundation for Intelligent Physical Agents. Okay, now and I think IEEE standards. Okay, is a non-profit association of companies founded in 1996. Purpose to promote the success of emerging agent-based applications, services, and equipments. Okay, what is the purpose? To support this one, right? For interacting agents and agent-based systems developed by different companies and organizations. The goal is pursued by producing specifications. What are the specifications that help agent management and platform services, agent communication model and language, and set of common interaction protocols? Okay. This is taken from the Jade itself. Okay. So Jade development platform. FIFA conceptual model of an agent platform. This is the model, right? So agent platform, then services. So we already mentioned that these are all the services. Services means the program, okay, that you can use it to turn on the your agent, turn off your agent. Basically, we call it give the burst to the agent, kill the agent means die the agent. White page services, we already talked about several of these, right? Yellow page services, message transport services, right? And then optional services, agent, software integration, ontology like vocabularies, query ref, inform, right? Human agent interactions, so those are built-in classes for this one. FIPA conceptual model of agent communication, okay? Envelope encoding scheme, so you have the envelope, okay? It's transmitted transport protocol that you have, and then the message will have ACL message, okay, agent communication, okay. Then in the message you have a content, so content language, okay. So content is expressed in content language, message is expressed in ACL, and envelope is transmitted over transport protocol. And then in content you have symbols. Symbols belong to ontologies, right? So this is kind of a general model of communication for the agent, okay. Okay, how much FIPA is hidden by Jade to the programmer, right? Means as soon as if you are a student, you will say, Dr. Jignesh, I think if I have to learn this one, when I will finish my master's and PhD, right? I mean, if I have to learn this one, there is just no way for me. No, I don't have time to do power system, right? So the answer is you don't need to learn that one. You just need to be aware of this one, right? So how much of FIPA is hidden by Jade to program? No need to implement the agent platform, right? AMS, DF, and ACC executed at startup, all of these things that we talked about. Okay. No need to implement agent management ontology and functionalities. An agent is registered with the AP within its constructor. Okay. It is given a name and an address. The agent class provides simplified interface to access the services of the directory facilitator, registering, searching. Okay. No need to implement message transport or parsing for protocol is available. You don't need to do anything. You just need to send message and receive message. Okay, as if you are just sending a text message. Now it is automatically done by the framework when sending or receiving messages. Interaction protocols must only be extended via handle methods. Okay. Different communication models, right? Client server model, generally all the legacy system will have this kind of structure, client server structure, okay, and one probably a backup. Okay. Hybrid, so you can have a client server plus client to client as well, and this pure P2P. This is so anyone will go out, you still have communication, you can still run your system. Here if server goes out, everything goes down, right? But that is generally the case. When we talk about control center, that's what is this is a control centerpiece, right? Yeah. But ideally it should be like this, peer to peer, right? Ideally. So edge computing, the new technology, edge computing, I think will definitely help to do this. Okay? But cyber attacks, when you have this kind of communication, cyber attacks are very real and can happen. Okay. This is where the Jade has been used. Nokia, Motorola, Siemens, and many other places, right? HP. Jade runtime memory footprint is very small. New one probably a little bit larger than this one, but very, very small, right? 100 KB, even 1 megabyte nowadays, it should be just enough. Because of limited memory footprint, Jade can be installed on all Java-enabled mobile phones. Okay, any Java-enabled phone, any Java-enabled smart device, you can install Jade. Okay, and take advantage of it. Jade architecture, so multi-agent, distributed agent, right? Then you have a containers. And in each container, you can have multiple agents and they can be communicating with each other, right? See here, you can see wireless communication. You can have an agent installed on the phone if that phone is Java enabled, handle devices, computers, right? So Java virtual layers, virtual machines. That's what generally Apple does. I think it creates a virtual space for the Java. Jade functional model provides basic services necessary to distributed peer-to-peer applications in the fixed and mobile environment. Jade allows each agent to dynamically discover other agents and to communicate with them according to PIPA standard, right? And several of things that we already talked about it. Agents communicate by exchanging asynchronous messages. This communication model is universally accepted for distributed and loosely coupled communication. Okay, distributed and loosely asynchronous messages, right? Agents don't know anything about each other. Okay, they discover, they talk and they discover, send message. In order to communicate, an agent just sends message to a destination or another agent, basically. Okay. Agents are identified by a name. All messages exchanged between agents are carried out within an envelope, including only the information required by the transport layer, groups of methods and protocols. Okay. The structure of message complies with the ACL, right? ACL, this agent communication language defined by FIPA, and include fields such as variables indicating the context a message refers to and timeout that can be waited before an answer is received, right? Jade supports multiple parallel conversations. So you can have multiple agents sending multiple messaging to each other. To increase scalability, Jade provides the opportunity of executing multiple parallel tasks within the same Jade thread. Okay, includes a naming service, ensuring each agent has a unique name, and a yellow page services that can be distributed across multiple hosts. So you can have, you can install agents at different computers. I mean, that's generally the case. That's what we are looking for, right? It has graphical tools supporting both the debugging and management monitoring phases of application of life cycle of agents. Okay. Using these tools, it is possible to remotely control agents, even if already deployed and running. Agent conversations can be emulated, exchange messages can be sniffed, tasks can be monitored, and agent lifecycle can be controlled. Okay, that is available. Those tools are available in the Jade. Jade is very well suited to support the development and execution of distributed, machine-to-machine, multi-party, intelligent, and proactive applications. Okay, again, Jade is very well suited to support the development and execution of distributed, machine-to-machine, multi-party, intelligent, and proactive applications. Okay. Why Jade, right? So Jade is middleware that simplifies the development of applications. Okay, that is the reason. Several companies are using for different application sectors: chain management, holonic manufacturing, rescue management, tourism, and more. Okay. Distributed applications composed of autonomous entities simplifies communication and collaboration in order to achieve the working of the entire system. Hides all complexity of the distributed architecture so that developer can do development just on the logic of the application rather than the middleware issues, right? Such as discovering and contacting and creating the messaging and sending the messages, figuring out which IP address to send, from which IP address to receive, which port to send, receive, which port to send, and how to read the messages, how to extract the content from that messages. So everything is done by the Jade. Okay, so we focus on our concept. Negotiation and coordination. Jade simplifies the development of applications that require negotiation and coordination among a set of agents. Jade simplifies the development of applications that require negotiation and coordination among a set of agents, where the resources and the control logics are distributed in the environment. In fact, easy to use software libraries to implement peer-to-peer communication and interaction protocols are provided by Jade developers. Okay, patterns of interactions between autonomous entities. Productivity, Jade agents control their own thread of executions, and therefore they can be easily programmed to initiate the execution of actions without human intervention, just on the basis of goal and state changes. Okay, so what information that agent is receiving. Multi-party applications, peer-to-peer architectures are more efficient than client-server, that already we talked about, right? For developing multi-party applications, as the server might become the bottleneck and the point of failure of the entire system. Okay, I'm going a little faster, okay, so that we can talk a little bit more about the power system. Okay, so this one is like more Jade. Okay, so because Jade agents can both provide and consume services, they remove any need to distinguish between clients and servers. Jade agents allow clients to communicate each other without the intervention of the central server. So you can directly send message from one agent to another agent. You don't need a server. Okay. Interoperability, Jade complies with the FIPA specifications that enable end-to-end interoperability between agents of different platform. Versatility, Jade provides a homogeneous set of APIs, right? Application program interface, if I'm right on that one. Okay, so Jade provides homogeneous set of APIs that are independent from the underlying network and Java version. Okay, easy of use. Jade APIs are easy to learn and use. Jade APIs and ready to use functionalities allow to strongly reduce the application development time and cost. Okay, and some says up to 30%. Okay. Compiling the software. Okay, so you can go here, jade.tilab.com. You have this probably 4 zip file, and you can download it. Okay. License, open license. Okay. JDoc contains or gives link to tutorials, programmer guide, and documentation of all the resources. Jade library contains jar files. I think they now change. Initially, they had 3 or 4 jar file. I think they changed to just 1 jar file now, which must be included in the class path. Very important, class path. Okay. Jade source contains demo. Okay. File, example files, all several codes available. So everything is open. It's available. All the files are available. .java file. They are not hiding anything. Okay. This is the structure of the Jade. So you have this Jade directory. Okay. Then you have a library. So initially, when they had the initial version, they had 4 or 5 jar file. Now in the new version, I think they have just jade.jar. So they combine all this into one file, jade.jar. Okay. I think they still have demo and examples in the newer version. Some launching the platform, setting up the class path. You have to have the latest version of the Java, okay, and SDK development version means, right? So that you can compile Java C and name of the file .java, and then you can compile Java C file. To compile Jade file, you need to do some little bit additional commands on this one. Okay. So once you are successfully installed your Java SDK latest version, okay, and set up the path, you install your Jade and set up the path, and you once run this one, okay, that is this command, java jade.boot -GUI, or I think in the recent one is, I think, java jade.jar, then jade.boot, okay, -GUI. But I think you should be able to see it on that documentation, on that website, jade.tilab.com. Okay, once you have successfully executed this command, okay, then you should be able to see this pop-up GUI on your screen. Okay, it's again, it's independent of the platform, but generally I would say just go with Windows. Okay, Jade.core implements kernel of Jade, the distributed runtime environment that supports the entire platform and its tools. Okay. Jade.GUI contains general purpose Java components and icons that can be useful to build GUI for agents. Okay. And then you have a jade.lang.acl. So these are all the classes that you won't be able to see it actual, but you can use it, right? So that is ACL. But there are files available. All the ACL messages file.java file. Again, we don't, as a power engineer, it's just a lot of time, at least 6 months. If you want to just go through it, understand what has been done by the Jade, but I think we don't need to do that. Okay. Okay, so different packages here, different debugging tools. You have a sniffer agents. This is sniffer agent, dummy agent, okay, log manager. So all the communication that is happening, you can come and see it here, okay, basically. Some of the agent debugging tools, okay, what is happening. Sometimes you don't get the message from one platform to another platform. That is the biggest one. But if it is the same computer, then I think it should be okay. Means it should be. Here you are seeing these are the messages between agents, right? So this is how you are going to see the messages. Inform and some values here, request some values here, inform and some values between agents. So here that is some agent is sending the message to here, and this agent is sending to another agent. This is the message that you will be seeing on the GUI part. And you can definitely receive in your program and act on it, okay? There are other agents, okay, introspector agents, log manager agents, okay. Event notification services that this platform supports. 4 major events that already we talked about it. Each time an event is generated by a container, that we call it a main container, wherever you first execute your agent jade.boot basically, and then any other agent with another command window you execute, then you will add that agent into the main container. So then it will be the container. So second window, all the agents are containers. So you can have multiple windows of it with main container of the agents. Okay. So this is the basic execution model. So each agent will have a setup file. Okay. And it will be looking at whether I do delete file, do delete functions. Okay. Behaviors, all the behaviors, and then behavior will have actions and done. Okay. And then probably take down, right? If you delete, then we will, that agent is no longer in the system, it's gone. So you can, in runtime, you can add the agent, you can delete the agents. Okay. So many things you can do. Okay. A little bit programming with Jade. Okay. If you have not done, generally power engineers don't like programming, but the new world, we have to, as a power engineer, we have to know the programming. Okay. Anytime you are going to work in R&D, you are dealing with some kind of programming. Okay. But if you are working in the field like substation, probably you will be more like using it. But if you have some kind of expertise, some kind of hands-on on the programming, you can understand better what system you are using. So whenever you get a chance, apart from MATLAB, Java, C, Python, just grab that chance, work on it, understand it. Okay, very important. New world engineers uh, with power engineer with software knowledge. Okay, that's a new world. 10 years back, I think in our group, because we were software automation, we write algorithms, right? We don't care whether it is we are utilizing our memory fast, whether we are calling the proper variables, when we are calling the methods. So whenever we write in the companies, we write our program, we just crash it, okay, in that one. So they hire a couple of computer science. So when we write it, computer science people will just see a little bit optimize it, okay, whether it's better for the real system, right? So they do all memory checking and whatnot. So it's very important that power engineers should have uh, uh, some kind of programming knowledge. Okay, new world. Anytime when you program hello world, that is the first Java hello world. A type of agent is created by extending this class and redefining setup method. Okay, each agent instance is identified by agent ID. Okay, that is j.core.aid. And agent ID AID is composed of a unique name plus some address for that agent. Okay, so where that agent is located. An agent can retrieve its AID through get AID. So if you want your agent ID, you can just use this method or function, we call it. Okay, simple program, hello world. Okay, so this is hello world.java file, importing this. Okay, and then we are saying public class. Okay, this is our agent, is extending the agent in the JADE. Okay, when you extend this, you are inheriting all the functionality that is JADE is supporting basically. Protected void setup agent must have the setup method, right? So we have a setup method. In that we are just saying hello agent, my name is get AID, get local name. My GUI ID means, right, get AID, get name. Okay, so it will print on your screen what is this. Okay, and if we get time today, we will do it. If not, we will do it tomorrow. Okay, I'm still working on it, so I have not figured out this, but I think if I get time, probably I should be able to at least show you this running. Okay. Okay, so how you do it? So you go to the location where this file exists in your command prompt. So you go to the location. Let's say this file is in CJAD example and hello world. So JADE directory, example directory, and hello directory, in that this file is located. So you go to the prompt here. You go to CJAD example and hello, right? And then you compile this one, okay? And then you run this one, j.boot, and then this you say that my name, agent name, hello world agent name is agent 1. You can say A1, whatever you want to say. And 3 things we are printing, right? 1, 2, 3. So these 3 things, once if this is successful, you should be. So when you compile this one, Java is going to create the file hello world agent.class, okay, in that particular location. Okay, and then this command will be to execute your agent using JADE basically, okay, with the help of Java. So hello world, I am an agent. My local name is this, my GUI ID. So it has all the other address and whatnot, okay. Okay. Agent initialization, something like that you will see on your command prompt when you write java j.boot -GUI. If your class path, if you have installed, but if your class path is right, that is the biggest challenge, okay, to run this Java platform, okay. We'll try, okay, we'll try today. If we can do it, that would be great actually, okay. Okay, so local name agents names are of the, I think we should take a break here, okay? We have a couple of more slides on this one. And then probably, let's see. I need to talk about multi-agent system and mobile agents, okay? That is next topic after that. And after that, if we have time, then we probably will go and spend time a little bit installing this one, okay? I will be sharing some files to you and see if you can install it, okay, Jade? But if not today, but definitely tomorrow, we will do it, okay? Okay, so let's take a maybe 10 minutes break, okay? And then come back. Let's say 10:15. We'll come back at 10:15. And we'll go up to 11:15 then. Okay, so let's take a break now. Okay, I am back and I am working on for that for Jade software, and let's see if you guys can download it. Okay, so give me like another few minutes to share a link with you. I'm still working on it. Dr. Prerna, I probably will be logging from another computer, so please allow me to join from another computer. Okay. Thank you very much, Dr. Prerna.
Recording in progress.
Okay. Yes. So hope you get my chat message and see if you can download that file, okay, and unzip it. If someone downloaded it, please write in the chat that you have downloaded it successfully. Okay, good. Thank you, Selendra. Okay. Once you download now, unzip that files. Okay, you should have a couple of folders. Okay. So you need to create a Jade folder in the C, in your C drive. Okay. So let's see. I'm just still looking for the class path. So create a Jade folder and put all the folders that you unzipped into that Jade folder. Okay. Okay then. Okay, very good. So now you can go to Java, search for Java SDK. So go to Java site and install the latest version of SDK. Let me see what I see here. Download, search for download Java SDK. Okay. Okay, 1 second. Hold on. Sorry, not SDK, JDK. Java JDK. Okay, SD, not JDK. JDK. Yeah. So most likely this should be the link. Okay, I'm sharing in this file here. If we install that one. I don't know about Mac. Okay, so you can install. Yeah, it is there. If you see that one, you have Linux, Mac, and Windows. If you click the download link that I just sent in the text message, it has all systems, Linux, Mac, and Windows. So default looks like is Linux. Okay, so you should be able to access it. Yeah. No, just one file, one installation. Okay, let me see what you have to download. So whatever your version, Windows, let's say Windows, go to Windows, and Windows out of all three, you can just download probably 153.38. So let's see if we can. So for Windows, it depends on what machine you have. Okay, but see, for 64-bit, that's the machine, and this is the download. So this is for Windows 64-bit machine. Okay. I think installer Swati should also work. Okay. So is how you do it. Okay. Yeah, it depends on your system. That Sailendra, I don't know. Okay, but try that one and see what happens. Okay. Remember that I will not be able to debug your things. I am trying that so that you can install it, because it's just beyond my capability here. But if we have a couple of students here who has done it successfully, then probably they can share their email, and then I can ask you to contact them. I think that's how we should do it. Okay. And we should not spend more than 15 minutes of time, because I also have to cover other things. Okay. So we have until 15 more minutes, and that's all. Okay. So let's do it in 15 minutes. If we can't, then you will be on your own. Okay. But at least I will give you the major part that I think most students or myself, I was struggling. Okay. So I will address that, and hopefully some of you should be able to install it. Okay. And tomorrow, tell me if you are able to do it, and then I will give your contact with other students. Okay. And then you can work together and do it by yourself. Okay. Okay, good. Okay, so that is done now. Open command prompt. Okay. So once you have copied this, install Java, type CMD. Okay. Command prompt. So let me share, Dr. Prerna, I think I will share my screen from here, this computer. Let's see. Okay. Thank you very much. And then just type, if you can see my screen. So just type CMD. And if you have the proper installation of Java, okay, so it's Java C. If you type, then you will see some kind of message like this. Okay, Java C. If you don't see it, that means you have to figure out how to set up class path in your Windows machine so that it can recognize this executable. Okay. So Java C, that is the first step. Okay. Second step, you need to go to your environment. Where is my environment? Somewhere I opened it up. It's Windows machine, so I don't know. There is all the files I can see somewhere. Well, let's see. Environment. If I type environment here, edit system environment variables. Environment variables, if you can see it, and use variable for this one, system variable. I think let's see if I can say edit. Okay, so I created this one. Okay, so edit, edit. Okay, now if you say new, okay, so you can see here on the new, if you can see it, you can just say class path in the new, and the value here, that what you will be writing. Okay, value what you will be writing is this dot colon. Okay, so dot colon, and then C colon slash Z. You can screenshot this one so that you will probably can write it. Okay, so class path, this all your jar files, that is in bin, and what was another folder. Library. and then commons codec. Okay. So you can see this. So you should have this jar file. Okay. And so this whole path you should be adding there, and all this jar file that is you are already seeing on this one. Okay. And then you just say okay. Okay. Basically, and edit new, you write class path dot colon, and then all, and separated all the jar files separated by colon. Okay. Semicolon, sorry, not colon, semicolon. Okay. And just say okay, and you should be able to create it. If you have done successfully that creation, okay, then you should be able to see this one. Okay, so Control C. Yeah. So you should be able to just write java j.boot. Okay. And you should be able to see your GUI agent like this. Okay. So these are all the agents that you should be able to see it. Okay. Swati, new variable, you should be adding this. Okay, let's see, where did it happen? So you go to environment variables, okay, then you say new, and in the new, okay, let me write here, class path, okay, then dot, semicolon, C colon slash jade slash library slash jade dot jar. Okay. So all the jar files, then semicolon again, C jade slash library slash IOP dot jar semicolon C colon slash jade slash lib slash jade tools dot jar. Okay. And then where is other files? Okay. Okay, and then you will have other files here. Okay, J tools we got IOP, HTTP we need C colon slash jade slash library slash HTTP dot jar. Okay. Then again colon C, sorry, semicolon C colon jade slash library slash common COMMON commons that codec slash common dash codec dash 1.3, and I think we need to leave it like that. Okay. So that's it. Okay, I don't know whether you need to do semicolon or you just need to leave it like this. So you need to try both. Okay. Let me see if I can tell you whether we need to write semicolon or not. Yeah, somehow it's not allowing me to see that way. It's just opening like that. You also need to add these two paths. CJade classes, CJade source example hello. Okay. So after, let's say, go back to new, what we added, we also need to add, sorry, dot jar here, then semicolon C jade examples slash hello C source example, I think. So, no. And then semicolon, C colon slash Z slash classes. I think that should be enough. Okay. So let me just paste this one. I don't know in the last, if someone is expert here, the last whether we need a colon or not. That part I am not sure. Okay. I'm sending that to chat message. Okay. Something like this. Okay. You should have it. Probably you are seeing my wife's photograph there because this is my wife's computer. Okay. Okay. We have a couple of minutes. Okay. And then we will jump at like 8 minutes. 8 more minutes we will spend here and then start our lecture. Okay. Okay, I think that should be enough on that one. You should be able to see it, figuring out. Remember, this one is older version. Okay, I have not worked on the newer version because in newer version you have only j.jar. But if you understand this one, so then you should be able to make it work for newer version as well. Yeah. Okay. Once you have it, if someone can say that you can see Java C, at least one student able to see Java C, proper message on the Java C like I am seeing. Java C, Subal, you can see that on your screen like mine, command prompt. Same thing you are seeing. Okay, great. Subal, Subal. Right, Subal. Subal, are you okay for me to share your contact with all the students who has some difficulty and you can help them? How you set it up, Subal? Okay, then that's good. Thank you very much. Okay, so once you have this one done, okay, and then you should be able to write, like I said, from anywhere on the command from Java j.boot -GUI. Once you write this, if your class path is set up, you don't see any error and you should be able to see this window pops up. Okay. And if it is not, then something wrong with your class path. Okay? So here, this is what I got, right? Something like that you should see on your screen. A older version here. Agent container, main container is ready. Okay. We have at least one student seeing this message, able to set up the class path. So after that, you go to Hello World agent. Okay, that is located at this directory CZ examples hello. Okay, so you go to your Windows browser, go to Jade examples, sorry, and hello, and then see if you can compile this one more time. Okay. If I can compile. So I'm coming out. I will say Java C J.boot. Hello world agent. Okay. Let's see. Probably I may not have to write Java boot. Okay. So you go to this location. You just say Java C hello world. Okay. But before you compile, just remove this one. Okay. Package, because I am not sure how to call when you are using packages. Okay, so I just uncommented this line. So commented this line basically. Once you comment this line, and if your setup is right, you should be able to do Java C. Okay, and when you do Java C, you should see your new file that is just created now, like just few seconds ago. Okay, and once you have this one, okay, you have 3 more minutes. Okay, then you should be able to run your agent, right? So now you are seeing, please note these two windows. Okay? So this is your main agent, right? Main agent container. Now we are running just a hello world agent, and we are saying minus container. So it's going to look for the main container, and it will add this container into the main container. So you will see that message here. Okay. So I am just executing one more time. Okay. Okay. So it's successfully, and you can see all our printing that we were doing in that. My name is this. Okay, agent, and then it is adding a agent container this to this one. Okay, so probably in that one we have only one command. Okay, so we have only one command. Okay, so you can basically type this one here. Okay, here. So that is only one command we have. My argument is the system printout. Okay, that's it. Okay, so I will give you 2 more minutes. Okay, and Subal, 2 things, right? You have controller, sorry, 2 windows. In one window, you write this one. Copy, and I send a chat. So that is on one window. Another window, you write this. First of all, you go to that location, right? You go to this. So I will type everything, okay, here. So you go to this location and then execute this command, okay? But before you execute that, you must comment this. Okay, just comment this here. Comment, just add 2 lines before this package, okay? And once you have done that, you have compiled successfully, then should be able to run this one, okay? Okay, so I think we are running out of time now, but this will be the last command, okay, that you'll be doing this. Okay, and then you can work on it. Again, it takes at least 2-3 months of time before you can understand what's going on, okay, and then probably 6 months before you can really write it, okay, the communication part, okay. But someone has to be interested to do so, right? let's say. Okay. I'll be coming back in like 30 seconds, okay? Okay, I'm stopping. Stop sharing. Great. Sharing from here. Okay. Okay, so we already saw that hello world agent, right? That's good. Okay, now all your attention here. Okay, so now whatever you could do, you have done it. Okay, so now let's give me like all next 25 minutes or 30 minutes here. Okay, and then we will go for the dinner, or I will go for the lunch, and then we'll meet tomorrow. Okay, so let's see where we were. Okay, so this is the first one that we executed. Okay, and then you should be able to see something like this. Hello world agent. You can also go to the main container. Okay, and also execute. If you want to execute from the GUI, you can execute new agent from here. So there are ways you can do it. And then you can see from that, agent names are the form of local name and the platform, whatever the platform that you are running, local host, probably you will see. The complete name of an agent must be globally unique. The default platform name is main host, main port, and /z. The platform name can be set using the dash name option. Okay. Within a single Jet platform, agents are referred through their names only. Okay. So now if you are running, let's say if I am running my agent here and you are running your agent in your computer and you want to add your agent into my container, so you need to provide the host name of my computer and it should be able to do it. Okay. If there are no firewalls, of course. So we should be able to communicate through that one. Again, given the name of an agent is AID, can be created as this, right? This is a Java language, okay, programming language. The addresses included in an AID are those of the platform, message transport protocols, and are only used in communication between agents living on different FIPA platforms. Okay. It is possible to pass arguments to an agent. So if you have arguments, argument 1, argument 2, and you can have hundreds of arguments here, okay? And then you can retrieve the argument in the program. You can just say get arguments, and then you can loop it all the things, okay? So probably here, arguments, argument 1 and argument 2, we are just giving. So here, this is the code for that one, arguments, reading, and then we are saying length of the argument, like argument length here. Okay, and then you can just printing whatever the argument is. Whatever the means, argument we need it for neighboring agents, right? Or the agents that you, or maybe the knowledge, self-knowledge. So you just create one agent, and each agent can be can have different parameters for different locations, right? So you have one file, but you can have multiple agents running and different knowledge. They have different fault level, right? I mean, number of counts, right? We saw that number of counts in that example. Different agent will have different, but it's doing the same thing, right? So you can have that as an argument. So that is the self-knowledge it is called. Okay. Do delete function, take down functions, right? So you can just say do delete, okay, take down, and you can just say bye, so that agent is gone. You can add, put something that what agent is deleted. You can say get AID here, print it here, right? Add, and you should print it that the agent is gone from the system. Behavior, okay, so OR, and so don't worry about it, means, right? It's UK English, and so I'm probably in some my presentation UK and American English are getting mixed up, okay? So we generally use you in India, and we don't use you, okay? So the actual job that an agent does is typically carried out within behaviors, okay? Behaviors are created by extending this class, okay? j.core.behavior.behavior class. Like in here agent, we wrote here, right? Extend agent. So you can write extend this behavior in that agent, okay? To make an agent execute a task, it is sufficient to create an instance of the corresponding behavior subclass and call the add behavior. Again, this is probably beyond what you know, but if you have some kind of experience, you can understand at least the process, okay? So add behavior method of the agent class. Each behavior subclass must implement action method, which doesn't return anything, void, and done method that which return the boolean, okay? That is, an agent can execute several behaviors in parallel. However, behavior scheduling is not preemptive, but cooperative, and everything occurs within a single Java thread, okay? Behavior switch occurs only when the action method of the currently scheduled behavior returns. So it has to complete that behavior before it goes to the next behavior. Programmer defines when an agent switches from the execution of one behavior to the execution of another behavior, okay? Advantages of this approach: it allows single Java thread per agent, especially in environment with limited resources such as cell phones, right? It provides improved performance since behavior switching is faster than Java thread switching, okay? It eliminates all synchronization issues between concurrent behavior accessing the same resources. So we don't need to worry about it if we are accessing this, because it is already taken care by the JADE, okay? So one shot behavior, right? So here they have already made the program for us. Is we can just say extend my one. So this is our, when we are programming in the agent, so where that agent has to do only one thing. So you can just program that, and then it will be done. So then you can write whatever you want, right? First, probably it will say, okay, register to the name server agent, register to the facilitator. That is kind of one sort behavior, right? So that you do that one. Cyclic behavior, where you want, like in our case, when we repeatedly just want to take the measurements, right? A cyclic behavior, repeatedly we just want to take measurements from the sensor. So we are doing repeated tasks. So that is cyclic behavior. And then you can also add that how many seconds, how many milliseconds you want to execute this behavior. So automatically can be done. Okay, cyclic behavior. It's already programmed for us, right? JADE provides two ready-made classes by means of which it is possible to easily implement behaviors that execute certain operations at given points in time. Waker behavior. So each behavior will have action method, done method. Okay. In Waker behavior, it is saying action and done method are already implemented, so that the on-wake method is executed after a given time out. Okay. So wake behavior. So we are saying this is 10,000 probably milliseconds. Okay. So 10,000 milliseconds. So after 10 milliseconds, it will call this on-wake method. We don't need to. We just need to give time, and then agent platform will take care of it. Okay. So after 10 milliseconds or 10 seconds, 10,000 seconds, 10,000 milliseconds, that means 10 seconds probably, it will call this method automatically and perform this operation, whatever you write here. Okay. Ticker behavior. So the action and done method are already implemented, so that the on tick method is executed periodically with a given period. So here is periodically. Okay. So every 2 seconds basically is calling on tick method. So wherever you need this, whatever your applications. Okay. And you can definitely relate this now with all the applications that we talked about, right? Because every time we need it, right? So on start method of the behavior class is invoked only once before the first execution of action method, suited for operations that must occur at the beginning of the behavior. Okay. On end method of the behavior class is invoked only once after the done method returns true, right? Suited for operations that must occur at the end of the behavior. So very good. It's already programmed for us. Okay. Each behavior has a pointer to the agent execution. The protected member variable my agent, right? My agent. So my agent is, when we say my agent in the program, so that means you are talking about that particular agent. Okay. So every agent, you can have my agent method. Okay. Remove behavior method of the agent class can be used to remove a behavior from the agent pool of behaviors. Okay. When the pool of active behaviors of an agent is empty, the agent enters the idle state and its thread goes to sleep. Okay. See, this is what is happening. So we have agent one. We already saw that our runtime, whatever you saw, that was main container. This is how it is, main container. And on another container, we executed so hello world agent. So think of this. So now agent one, prepare message to send agent two, is sending the message, is going into the queue. Whenever this agent has a time, it will go back and read that message. That's generally the architecture of this one, communication architecture. Each message includes following fields: sender, list of receivers, okay, communicative acts, okay, also called performative, indicating what sender intends to achieve by sending the message. Performative ontology we were mentioning, so requests, agent is requesting information, agent is informing to another agent, that's the performative. Agent is proposing to do something or call for proposal that I open or close, I am offering to provide additional power to this one, content, and the conversation ID. Okay. Messages exchanged by agents are instances of the ACL message class. Okay. Provide accessor methods to get and set all the fields defined by the ACL messages. Get performative, set performative, get sender, set sender, and all other methods. So it's already available. Again, like I said, at least 3 months. If you are planning to do, I think, I don't see a student there. Okay. one student was doing UK probably. Sending a message is as simple as creating an SCL message object and calling the send method of the agent class. Okay, so this is message.addReceiver, message.setLanguage, set ontology, set conversation ID, set content. Okay, so that's the message. We are creating a message that we want to send. So this is the message class probably, and then these are the content that we are adding on to this message. Now, reading message from the private message queue is accomplished through the receive method. Okay, so when you say receive message, so it is going to receive the message that is being available here. Okay. Blocking a behavior waiting for a message. Okay, a behavior that processes incoming messages does not know exactly when a message will arrive. Okay, that is, so you won't know when the message will arrive. So from your perspective, from your agent, you can just poll the message. If there is a message, you will receive it. If there is not a message, you will probably receive null in your method. Okay, so it should poll the message queue by continuously calling my agent.receive. Right, so you have to every 2 seconds you want to call, every 5 seconds, whatever you want to call. Right, this of course would completely waste CPU time. Right. The block method of the behavior class removes a behavior from the agent pool and puts it into a block state. Okay. Each time a message is received, all block behaviors are inserted back into the agent pool and have a chance to read and process the message. Okay. The receive method returns the first message in the message queue and removes it. Okay. So once you read, message is gone from the queue. If there are two behaviors receiving messages, one may steal a message that the other one was interested in, right? Because it's gone. One behavior read it, and if you want that same message in another behavior, you have to take care of that in your program, in your agent program, okay? So because it's not now no longer available here once it is read in. So if you have 10 behavior, means kind of 10 functions, right? And out of 10 is 2 is reading, looking for the same message. Whoever reads it first, second will not get it. Okay. And most of these behaviors are executed asynchronously. So you won't know which one is executed first and which one, unless you program it right way. Okay. To avoid this, it is possible to read only messages with certain characteristics. So example, whose sender is specifying the template. Okay, so you can some kind of restrict, right? When you want to receive it, you don't want to receive the messages or letters that are your neighbors, right? If you see a neighbor, then you can just give it to them, right? Very similar concept here also. So you can program it, okay, this behavior is reading inform messages, okay, or inform messages from these senders, okay, and this second behavior is reading query refer messages from these X agents, okay, so that way they will not steal your messages basically. Okay. The receive method returns the first message in the message queue and removes it. Okay. The agent class also provides the blocking receive method that returns only when there is a message in the message queue. Okay. So very good, right? So that means we are not wasting the CPU time on this one. So it is just going to wait for us. It is dangerous to use blocking receive, though there is a catch here, right? So it is dangerous to use blocking receive within a behavior. In fact, no other behavior can run until blocking receive returns. Okay, so that's no, I would say not to use it because we have multiple behavior and we need to execute multiple asynchronously. Okay, so if you use this one, then all the behaviors of that agents are stopped now. Okay, unless and until you are sure that when you are blocking this, you are blocking all the behaviors, and you are blocking receive means you are expecting that message is going to arrive. Okay. Again, a lot of details on this one, and it's important, at least if you are planning to program it, okay, and at least give you the flavors, okay, So you don't just generally jump into it, okay? Unless you are sure that you want to use it and spend your next 6 months or 1 year of your time. Okay. Use receive and plus behavior.block to receive messages within behavior. Use blocking receive to receive messages within the agent. Setup and take down methods only, right? Okay, what are the input parameters? When FD agent declares that he has seen the fault, right? Feeder agent. What feeder agent has to do when it declares that he has seen the faults? Okay, just a starting point, right? What feeder agent has to do when other feeder agent sends a message indicating fault? So this is kind of gathering the knowledge, brain drain, right? So what needs to be done? Architecting your architecture, you are creating the architecture for your fault diagnosis uh, uh, multi-agent system. Okay, so you have to pay attention to it. You have to see the system. You have to do lots and lots of simulation before you can come up and with the right answer to these questions. Okay, and once you have those answers, then you can think of what types of agents we need, what types of messages we need to do restoration. Okay, what are the input parameters? Okay, so in this case, upstream and downstream agents we need to know, right? Location where it is taking measurements, we need to know, that agent has to know. This information should be an input argument to each agent and implemented in the setup method of an agent. Okay, so what are the information? Upstream, downstream, location where it is taking the measurements, and it has to be included in the setup method. Okay. Okay. When FDA agent can declare that he has seen the fault, okay, it depends on system parameters, right? To answer this one, when FDA agent can declare that he has seen the fault, depends on the system parameter for sure, right? But generally 3 to 5 times larger than the largest load currents, right? 1.5 times if you have seen generally largest load current, right? Then we can say that most likely my agent has seen the fault. Need to find what is maximum load that substation or feeder can supply, right? If it is asking the restoration, then this agent has to find where is my other agent and other feeder agent and how much that other feeder agent should be able to supply, just like we saw on another example. Are we closing into the fault? Are we overloading, right? Those are the question. And if answer is no, then only we can close that tie switch. If answer is yes, then we need to figure out how we can deal with that. Okay, what system, how system we can create it on this. Okay, and okay, so these are, let me see, let me stop here. Let's go to the JADE website here. Share this one. A lot of materials, tutorials are available here. Okay, and programming tutorials, programmer's guide. So a lot of tutorials are available if you want to use JADE or there may be other softwares out there. Okay, and then programming tutorial here. I think I prepared this programming from this tutorial only, most likely. Okay, so this is the basic model of an agent. Okay, do done method. I think, yeah, this is where I took some of the slides that I presented, like this one I presented, remember. Okay. Okay. And what others? We have some examples. Okay, so hello world example, behavior examples. Okay, this one, see how it is saying you need to execute this one, right? And where is the download one? Okay, so go to here. Okay. So these are some of the files. Okay, but if this part is very important on this one. Okay, so in the new version they have, instead what we wrote is Java j.boot GUI, but now they are adding this too. So -cp stands for my class path, and then you are calling lib. So you are executing this from the J directory. So you are in CJ, and after that you are typing this. Okay, and if your all class paths are right, you should be able to see what we just saw in our case. Okay, but it doesn't. It has in newer version. It just created one file instead of 5 jar file. Okay, but this is the new command basically. Okay, but very similar for power system perspective on this one. Okay, and one more thing, I think fax device, someone was asking about, okay, and I think I might mention this one, okay. When we talk about fax controller, where is images? Okay. When we talked about in our lecture, right, in yesterday, fax device controlling. So it's not just simple, right? It's very complex. So this is a fax device. So you are basically in real time, you are changing the impedance of the line. Okay, so I are increasing and decreasing of the line, and this is in thousands of megawatt. That is, this line is carrying, right? So it's huge. It's not just simple when we are talking about just sending a control, right? You need to understand this one. So these are all different implementation of the fax devices. Okay, on this one, how big and how small. Okay, and so tomorrow I think we will go over one more application, and then we'll start talking about numerical methods on that one, and probably we'll do one MATLAB examples on that one tomorrow. And the last lecture will go a lot on the microgrid side, and let's see how it progresses tomorrow. Probably we may start talking about microgrid tomorrow as itself. Okay, so I think it's a good time that we should stop here and see if you have any questions that I can answer. Okay, general question. Probably exhausted by now. Monica, it depends, right? If you are creating a market and if you are creating different traders, right? Generator company trader, then power company trader, then independent system operator. So it depends on your applications, right? But of course, if you have some kind of communication, some kind of distributed control, you can definitely use JADE. Okay. We already saw one example for electricity market, right? Power exchange agent, and then we have power producing agent and retail agent, and then user agent, right? So that is one example that we already talked about it, Monica. So definitely you can, it depends what exactly you are trying to achieve in electricity market, right? So if it is just a centralized, if you are just doing some kind of optimization, some kind of price-based unit commitment, or real-time price-based unit commitment, I don't know what you are trying to do. Okay, so if you tell me a little bit more, probably I may set some ideas that is coming to my mind, Monica.
Hello.
Yes.
There is a JD book 2003. After that, there is no book published in JD. Is there any development happening, or we still have to follow the same old book, which is published in 2003, I believe?
That is correct. That's the old book. There is no other development, Leo.
That means the practical application of agent still, because I don't find any industries doing agent, implementation, various operations. Is it growing or it stands still?
I really don't know the answer for this one, because probably they so like we'll talk about one software tomorrow, virtual test bed, okay, and that is gone from the earth, okay. But my understanding is gone because it was very good, and it was very good for the ship system, electric ship system. So United, probably Navy, used that software for their development, okay. But this one, Jade, is open source. And
If it is really operational, then many industries should come forward to use it. It's very useful means.
so
But
maybe
I find, yeah,
understood. Yeah, understood, Leo. So, but maybe there is no development, and they are already got the code for that. And once industry has it, they just don't want to reveal it that we are using the same technology. That's my understanding. Okay. Uh,
yeah, that's true because even I find that the publications are not really good publication coming in the agent side much.
right. Yeah.
So I also worked in agents long back. After that,
Okay.
much of application side, so then I stopped working in Jade. I operated Jade long back in
Okay.
2008 or 2018 or so.
Okay.
So after that, I don't find any practical applications in multi-age systems. A lot of theories, I implemented this JDA with, the sniffer diagrams and the communication, all those things. After that, I don't find how to link with the practical usage. So
That's correct, sir. I think, Leo, I think I read your paper, some of your paper also. Yeah, it's like now from 2011, they stopped implementing Jade system, Jade development.
exactly. Yeah.
I think I read one of your paper, your Leo, I think.
Yeah. Thank you, sir.
No, but so if you have to do decentralized control, what you will do? Tell me.
Yes, sir. Actually, that was my main problem when I came here, because we want to work like decentralized multi-agent system for active buildings. The problem is like which kind of software I should go with, because I don't have a programming experience before. I just have used MATLAB for optimization. So I have to sit a long time on Jade, understanding Jade and how I run with Eclipse. Loading the jar files, and how I have existing code with my colleagues. So I took them and I understand the existing code and I try to modify that, but I struck. So that's why I'm attending this.
I think that probably the issue means it's not like more user friendly, that software is.
Yeah.
So that is probably the issue that is driving.
And also, sir, there is one problem I found in literature these days, like they just tell multi-agents, but they don't use this software.
I know.
It's so funny, some papers.
Right. So I know, but that is an issue. Means if you
I also reviewed certain papers of IEEE papers also. Right. But even that papers, they're not implemented really. They just use the multi-agent word and do some peripheral works on it. But the real implementation is really missing.
Now there is no proper review paper also to suggest to keep the link in the chat. There is no good survey paper also.
Right. Yeah. No, I think there is a recent survey paper. I saw that in 2020 or 2021.
Yes, sir. I have a collection. I have a collection, sir. So maybe tomorrow I will find that review papers and I can.
Yeah, I recently saw one paper. Application of multi-agent system, like a review paper on smart grids. So I have not gone through too much detail. I have not gone through it, but I saw one paper, a recent paper on 2020. Yeah. Yes, but again, means we don't have any options. The problem is that we don't have any other good options for this one. And this one, it takes time. Okay, that is for sure. So if you are really keen for understanding decentralized control, what can be achieved, and ready to spend time on it, then it's a good tool, right? I mean, we don't have any infrastructure like communication infrastructure available to us as a normal users, right? It means like power flow is available to us, but no any communication. So if you can combine Power and Jade, I think that will be a good master's or even PhD level work. Okay.
So. Yes, sir. Actually, I have I come across two research areas now in this multi-agent system here. So one is a multi-agent system for multi-vector energy systems. So that is hot topic, like people are thinking in my research group here.
Okay.
And there is because peer-to-peer approaches are now popular.
Absolutely.
Even they are using blockchain also, but there is still centralized approaches are going on, centralized and decentralized distributed. Right. So we try to model decentralized or distributed approaches for peer-to-peer transaction.
Right. Absolutely. Absolutely. Yeah.
Thank you, sir. Thanks.
Sure. Yeah. Okay. Any other questions or any other discussions? Okay, then we can depart today, and we'll talk more tomorrow. Okay. Thank you very much, and have a good night, good evening to all of you. Yeah. Bye. Bye, Dr. Prerna. Thank you very much.